So, okay, I take this one. Good afternoon. It's very great pleasure for me to be here. I know that University of Kyoto is a wonderful university, and this is now my first trip to Japan, but that has been very intensive. This is already in a few days the third seminar I give. But the two first seminars were for non-scientific communities, and there I only focused in the general aspects of the Finnish educational system. But then we agreed with Professor Imai that now this is more a kind of scientific seminar with scientists, and I balance a little bit so that there is some general issues about the Finnish educational system, and particularly this kind of analysis we have made about the challenges we have, and then how we have tried to answer as researchers to these challenges, and what has been the impact of this research, and of course there are many things to do. But I only focus in this part of the research where what we have been doing in my own research group, and what has been the impact of that, and how it is how the themes of our research have been inspired by the findings of the in the Finnish schools and the Finnish educational system. Okay, first I go to some of the general issues. So that it's during last decades. In very many international comparisons, Finnish students have been among the top achieving students in the world. It has been varying a little bit depending on the year and depending on the international comparison study, but this kind of high-level achievement has been in reading. That was in fact the first one where Finnish students were very good in international comparisons, and then since that, reading has been one of the strength areas. In some measures also mathematics, but mathematics has always been a bit problematic in for example team studies. It has not been so good. In some PISA studies it has been very good. A little bit same in science, and then in foreign languages there is very brand new results showing that particularly learning English in Finland is quite good, so that young people, the English proficiency of young Finnish people is quite high in the international comparisons, and then also problem-solving skills, which have been measured, for example, in PISA and some other studies. But from the point of view of educational researchers, and I think that if we only focus on this kind of studies which are looking achievement in individual tests, it is much too limited and narrow view when we try to evaluate what is really the quality of a educational system. Educational systems are not should not be developed for producing individual good test scores. Educational systems have much larger tasks in the society. They have to contribute to the society in the much more kind of deeper way, not only in producing this kind of methods. This kind of broader evaluations of the functioning of educational systems have also been made, but not so much, and they are not so popular than these studies which focus on individual test achievement. One of these studies is the World Economic Forum study, which has evaluated in a more holistic way how educational institutions are contributed. In this case, more to the economy of the country, but some of the things are also related more broadly to the civil society and the development of civil society. And this is the kind of summary table of this World Economic Forum study of the global competitiveness report, which is relatively recent report. And they have looked first how the institutions are contributing to the society, and also the educational system as whole, and the educational administration and these institutions are included here in the institutions. And then what is related to education as well is then this aspect where they have looked how the society is taking care of health, well-being and learning of young children, so that they focus on health and primary education, and then they focus on also on higher education, so that in this overall analysis there are three kind of different perspectives which are related to education, and there the Finnish system made very well, so that it was evaluated as a world leading in these institutions, and also in the health and primary education, and then in the higher education system it was together with Singapore in the top, and Singapore was the world leading, and then Finnish higher education system was considered the top in Europe. And this is a different analysis than the university rankings, for example, which takes some few indicators, Nobel Prizes or publications in science and nature, and this kind of indicators, and then make rankings. This is analysis how the institutions contribute to the society and the economical development in society. And because of that, the results are a bit different. Then when we think from the societal point of view, the role of education, it is important not only to look the average results at how good test scores students get if we focus on the test achievement, but it is also important that how equally the system is developing students or giving opportunities for students to learn. And this equality aspect has been studied, some of the international comparisons, and recently OECD tried to summarize some of the achievement test results and compared them with an index they developed which describes how equally the educational support, the educational system is supporting students coming from different socio-economical backgrounds. And this table describes that comparison, so that we have here the test scores. In this kind, the test score is a bit different. It also explains a little bit this figure that it is a kind of based on a threshold value, that how big percentage of students have achievement which is above a kind of a threshold which is considered to be acceptable achievement in these measures, and there they combine different measures together. So that this is this line is a line how many percents of students are above the threshold in these measures. And one encouraging, and then the other dimension is describing how equal is the system. They have used this index which is developed on the PISA studies results. And now what is encouraging here is that there is a positive correlation between equality and quality of educational systems. That those systems which are equal, they seem to be also good for supporting the quality of education. And if there are systems which are unequal, then they hardly can have high-level results in these measures. Of course, there are also technical reasons why this relationship is so strong. Interestingly, Finland and Japan are here close to each other, so that both systems in these measures are equal. There is only small difference in equality, and they are achievements so that they are practically on the same level here. Our very small neighbor Estonia is here. This is a new development in Estonia. And there is also a Finnish influence because our universities, for example, the University of Turku, from where I'm, immediately after when Soviet Union collapsed and Estonia became independent countries, it used to be part of the Soviet Union. And then we got a big funding from our Ministry of Foreign Affairs to help Estonia to develop a teacher education model, and we sent a professor who lived there several years in Tartu and was developing the model. Now we are claiming that was wrong, that we sent the professor there, because now they are beating us in these international comparisons, and that happens in the world. Okay. So, but Finnish the achievement of the Finnish education has not always been so good, because this kind of international comparison studies have been made already in 1970s, and this strong development only started in 1990s, and then around 2000 there were several comparisons, but before that the achievement of Finnish students was about OECD average or below the OECD average in some cases. And now it's interesting to see what explains this development. Why that happened? And the second question, what I'm going to focus mostly today, is what is happening now there. And this is mainly now the mathematics figure where we see this decrease, and I come back to these issues later on. So what happens here and what happens here? These are now the topics of our study, our presentation today. Of course, in this kind of issues, we can, as a researcher, you have to be very careful that you don't claim about causal relations if you don't have data and designs which make it possible to say that these things caused that effect. And in this kind of overall processes which are taking place, we can never practically find convincing causal effects. They are only relationships, some time-based depending, so that the timing fits well, and then we can have also kind of logical explanations that some decisions which have made and some development which has made then cause these effects. And now the explanation in Finland is that this big educational reform which we were carried out in 1970s, and then the system which were developed at that time for the continuous qualitative development of the educational system might be one of the reasons. But as we have to be careful not to say that there's a clear causal relationship between that. So, and there was a relatively large political agreement that we need this large reform of our educational system. We used to have a typical European model which can be described as a very strong ability-based tracking system, so that there were only few years of schooling common for students, and then students were selected to different trajectories, and from the so-called lower trajectories there were no access to higher education later on, so that was if somebody went to the lower or was located to the lower trajectories, the consequence was that they only were able to get a very low level vocational training in maximum, or then go to the working labor market later on without any real professional skills. But it was clear that we need a better educational system than that. There was a very long experimental phase when this new model was experimented, so researchers contributed to this large-scale experiments where some municipalities changed the educational system according to the plans to reform the whole system. There was not yet this legal basis for that, and there was a kind of separate law accepted by the government that some municipalities can experiment with completely different educational system, and there was some variations in the way how it was done. And then also there was a lot of emphasis in curriculum development. Many universities were involved, a lot of teachers, school administrators, and this lasted a long time. And it was not only it didn't only focus on the subject areas, but there was a lot of discussing about the general principles, the kind of pedagogical background, this basic ideas of the whole education. And on the political level, there was two important things. So that on the political level, it was possible to agree about very general level aims for the reform, and there was an attempt to combine ideas of equality and quality. At that time it was very clear in international discussions that these are opposites, that if some system emphasizes quality, it cannot emphasize equality, or if it's focus on equality, then the system cannot be produce any high quality learning. But somehow in this discussion these both ideas, the aim was to combine them. Of course, the consequence was that it was a very long-lasting process, a couple of decade process to learn strategies, how these things could be combined better. And then on the political level, there were a decision of the basic school educational structure. But then one issue is very important, and it is that, this is partly due to the political system in Finland, because we have a lot of political parties, and we have no dominating parties, or there are several parties which are almost equal strong, and our governments are always coalition governments, so that many parties have to be there. Otherwise, they cannot have a majority in the parliament, and this means that we have very little this kind of radical political changes. If there are some changes, they are very gradual changes, and as a part of that situation, also the politicians somehow understood that it's better that on the political level we only decide about general aims and the general structure, and then it were the experts, school administrators, teachers, researchers, who developed the details, and this started the long-lasting process, which has now lasted 40 years. This kind of gradual development of the educational system, and this is very different from our neighbor countries. For example, in Sweden, where we had very similar situation in 1960s, they made a reform, this type of reform which we made a little bit earlier than we made, but after that they have made very many reforms where they have changed very basic ideas of the system. And one consequence of that is that there have been very little opportunities for this gradual research and the evidence-based development of the system, because these decisions to change the system are not based on the evidence, but kind of political ideologies. And they have very many times, based on the political ideologies, changed also very relatively specific details of the system. But that has not happened in Finland. Of course, there have been periods when there have been this kind of pressure. Some politicians have been thinking that, okay, now we have great ideas how teachers have to teach, or whatever. But this has never had very strong impact, and that I think this is something which is very crucial for this system, that there have not been so many these changes. And then what is important that this model, which was developed in 1970s, and then it was in the whole country in the beginning of 80s, this was not that well functioning in the beginning. There were so many things which were new, and teachers were not prepared to deal with these issues. But then this kind of systematic development started, which focused on these two basic issues: the equality and quality. And it was clear that in the beginning, during the first decades, the main focus was in building a system which supports the equality of the education, and then afterwards the different kind of projects and development took place, which was focused on improving the quality of the educational system. The first thing was this implementation of unified curriculum without any ability-based tracking system. In the very first years of the new system, there was still some tracking, but then in a couple of years we moved to this unified curriculum. At that time, in 1980s, when this happened, it was very seldom in the world that there was for first 9 years a curriculum where there were no systematic tracking, so no selection of students for different tracks, but the aim was to have the same basic core aims for everybody. There was and to make that happen, we developed a kind of Finnish version of a mastery learning system. Those people who was very much involved in developing the first curricula and the pedagogical methods, they collaborated with a little bit with Benjamin Bloom, who developed in the USA the master learning ID, which never had very strong impact in USA, but in Finland a kind of own version of that was developed. And then the basic idea was that because students, when they come to school, they have all kinds of differences. There are some differences in basic abilities. There is differences in prior knowledge, differences in their learning skills, due to the differences in their family background and other things. And the idea here was that then the task of the school is to very systematically analyze what are the individual needs of the students. If students come with very low learning skills, then they need much more teacher support, teacher time and teacher support, and also they probably themselves, the students, need more time to reach the same goals. And if some students come with very strong skills, strong prior knowledge, they in fact need much less teacher support. And but later on we noticed that what they need would be is a rich learning environment where these self-regulated learners can develop their skills. But basically this systematic allocation of teachers support teacher resources according to the student needs, this became a fundamental part of the Finnish comprehensive school pedagogy, which still dominates it. When we teach our students in universities, we very much focus on this issue, that how they recognize the needs of different students and can individually allocate the support so that we can guarantee that the results at the end of the schools are not bigger than they were when the students entered the school. If possible, they should be smaller. And then so far it is possible that we try to bring all the students on that level of the core aims of the curriculum. Okay. Then there were other things which was related to the equality. Of course, the class size is very important, so that there was attempt to make sure that teachers can allocate their support according to the to the individual needs. And if the group class size is too big, say too many students, then it is not possible. It means that the size of the class cannot be too big. And then there were also extra resources. For one model which was developed, it was that there was another person working in the classrooms, not a qualified teacher, so that the qualified teacher had the main responsibility, but the other person then helped the teacher in organizing the teaching learning process and in taking care of the support for those students with the special needs, or when the teacher had to focus very much on the students with learning disabilities or difficulties or weak learning skills, then that person helping could organize meaningful learning activities for other students. So that this made it flexible and also made it possible that this general aim focusing on the individual needs was possible. Then, of course, there was also then more kind of organized system of special education. We developed a model where there were first support in own regular. Yes, please. Have you?
Sorry,
Yes.
this is small class size and how many students?
So the small class size means in primary level it is about 24. In lower secondary level it's a bit more, but that has changed. It has not been a fixed number of. There have been variation, but in average it's about that, and then in lower secondary level then a little bit more, but below 30 was the ideal. So when we compare, for example, you probably have much bigger in the cities, but maybe in countryside it's big. But that's the same in many countries, that the class size is bigger than that. So that, of course, it was quite a big investment, and but it was not so big change in the whole system, because Finland is a country which is very large from geographical point of view, and the population is small, so that we have a lot of small villages, and we had the tradition already from the beginning of 20th century that we developed schools practically everywhere where people were living, and there were plenty of schools where there were 2 teachers and maybe altogether 12 students in the whole school in remote areas. And now in this reform, the biggest change was in the cities. For example, when I went to the primary school far before this reform, we had during the first class, I think 35 to 40 students, 35 about in my class. So that it was very much bigger, but mainly in bigger cities. But in the countryside, there was not big difference. So that because of that, it was not so expensive to make this system. But then the flexible part-time, the flexible special education system or special needs education, so that one part of that happened in the regular classroom, and then the second part was this part-time special education support in a small group, so that if the student had difficulties to learn to read, then the student was during some classes not in their own classroom, but with a special education teacher in a small group where they systematically diagnosed it, what are the problems in learning to read, and remedial teaching to support the reading skills. The same a little bit in the mathematics, but earlier this special education clearly focused on language skills, reading and writing, but then gradually also to some other subjects. And then for those cases who had serious behavioral problems or then seriously disabled children, there were special classes where there were only a very small number of students, and then specialized teachers supporting them, and even there were some separate schools, for example, for blind students and so on. But okay, this all even the special education, because there was the idea of this flexibility that students, if they get effective special education, they can return back to the normal classroom. This was a very strong ideology in developing this special education, because the special education, particularly this when it's a separate special education class, can be seen as a labeling process. That it's a kind of negative label, that or stigmatizing process. But there was very strong attempts to avoid that with this flexibility idea. And then there was some in the system we gradually moved to look more at the quality. One very important thing was I don't have today very much about the teacher education model, but we created a new teacher education model, which was aimed to be very high quality teacher education model, also focusing on changing the whole idea of teacher profession. And one important aspect of that was increasing autonomy for schools and teachers. And then also that was related to the idea to develop a trust-based model in the system, so that if the teachers are highly educated, if they have a kind of very high professional identity, then it is possible to trust them, and we don't need this inspection, and we do need high stakes testing. But the whole assessment system was developed from different point of view, so that the assessment was not controlling teachers and schools, but the assessment was developed for supporting the pedagogical development. So that then the solution was that we gradually developed a model that we in a relatively intensive way made sample-based tests. They can be achievement tests in the school subject, or focus on motivation, or focus on learning skills, learning to learn skills, and also functioning of the classroom processes, or the kind of pedagogical leadership in the schools, and this kind of aspects. And this idea is that the leading school authorities, they do not get any detailed information of individual schools. They get this kind of average information, and also the schools get the same average information, and then they can the teachers themselves compare what is happening in our school or my class, and how it is related to the national national average in some subject, or are these features typical in my schools? What could be made better? So that the main idea of the whole evaluation system is to help schools to develop themselves and teachers to develop themselves. And that's quite different from the high-stakes testing idea, where it's the controlling aspect and also the kind of avoiding or punishment aspect very dominating, and we try to avoid that. And I remember I was vice chairman of the evaluation council when we reorganized the national evaluation system in Finland, and the first council was founded. And we carried out many these kind of sample-based evaluations, and our media, the leading newspapers, wanted to get detailed information that how well individual schools are doing. And then we said that we don't analyze that. And then they hired lawyers. That okay, we have to give, because there's a kind of model in Finland as administration have to be open, so that media has right to get detailed information about administration. But we thought that okay, but this knowledge doesn't exist. We only have the average results, and this information, school-based information, doesn't belong to our task. So that we cannot give this kind of information what doesn't exist. Of course, it existed, but still, finally, they didn't get that information. But this only shows that it's not so easy in the societies to maintain this type of model, because the idea of controlling and presenting rankings and so on, this is so strong tendency also in our country. Then we had a lot of work on this research-based development of the quality of teaching learning processes. Now what I'm going to talk at the second part of my talk then is give some ideas how that has happened in the field of mathematics. And then one important thing was that after this first development step was more or less has been more or less successful, this building the equality, we noticed that the way how knowledge is defined in our curricula, what kind of ideas of learning there is in the system, and what teachers think about learning is not the most advanced one. So that there was in 70s, 80s, 90s a lot of very intensive research in the world about the teaching, the learning processes. The whole notion of learning developed very much when we think about this higher order learning, the deep learning approaches, and we in Finland we organized a very intensive discussion. Researchers were leading this discussion, but it went to practically all schools in the country, where we discussed about the conceptions of knowledge, conceptions of learning, and introduced this kind of general awareness of the deep learning idea. Okay, and there the focus moved a little bit from this just teaching different pieces of knowledge, and focus moved to learning skills, strategies, cognitive strategies, and metacognitive skills, and these became a part of the official curriculum relatively early on. Of course, they are nothing new nowadays. In every country, these things are highlighted in curricula, but we pushed them quite early in this system in Finland. And then development of learning environments, use of educational technology, and then focus on motivation and student welfare came more important parts of it. So, okay, this was now kind of a description of this background, which more or less created. Now, one important aspect was missing from this presentation, but it's such a long story. The teacher education model. We already discussed before this started that there are some people interested in the Finnish teacher education model, but in the discussion we can come back to that, so that I couldn't deal with that in this more. But okay, now very recent international comparisons have made clear that there are some weaknesses in achievement. Achievement is and these problems we particularly noticed among boys. And if you look the international comparison studies and divide them so, the very recent ones, that there are only girls from different countries are included, then the Finnish girls are on the same level than girls from Singapore or Hong Kong, Korea, not South Korea, but or Japan in mathematics. But then if we look at the boys, something strange has happened among the boys. And earlier it was clear that boys had higher achievement than girls. Then they were on the same level, and now girls have, even in mathematics and science, a little bit better achievement than boys. In reading, it was of course opposite in Finland and many other countries, that girls always have been much better in reading and writing than boys. But this has been kind of alarming situation, what is happening there. But the problem in mathematics, and I now move to mathematics, was in fact already visible in national surveys and these national evaluation studies, and also the more focused studies, for example, our own research group. Far before this change started to happen in PISA studies or some other international comparison studies. And first there was a decrease in motivation of mathematics, and then even though students still were relatively good in problem solving, but then when we looked at the conceptual understanding, that was not on the level that then would guarantee that also in future they would learn mathematics in the relevant way. So all this was known already before this changes in the international comparison studies did show some changes of Finnish students. Now I don't go so much to this boy question. This in this general lecture about the Finnish educational system, I was particularly discussing that because this seems to be a more broader societal question, and schools, there have nothing happened in the schools which has caused it, but there are general changes in the society, and then the schools have not yet been able to react to that in the adequate way. But I I go to mathematics. And one of the findings was that in our local studies, that when children come to the primary school, there are already very big differences in their mathematical thinking, in this kind of very early mathematical skills. And that's of course the same also in reading. But then when we follow what happens in reading skills, when school starts, then the differences, achievement differences, decrease. But in the mathematics, it's on the opposite. In the mathematics, these relatively big differences which are when the children come to the school, they increased. And because of that, we are thinking that now it's very important to focus to that question, that what happens before students come to the school. And then the other thing was the motivation. These studies, these domestic studies, did show that somehow students were considering mathematics as something completely isolated, so that it's not related to anything. And because it's not related to anything, they were not quite many of them were not motivated to study mathematics. So that somehow this kind of natural numerical thinking what children already have before school age didn't continue in the beginning of primary school, but mathematics became this kind of isolated things. And this was the starting point for our the different aspects of our studies on long-term development of number concept. And they were clearly based on these findings on the system. But maybe before I go to that, do you have now questions or comments which are related to this general part of the educational system? Maybe it's better to have the, because you remember better what I have been telling, and now you could ask questions or comments about it.
前半部分に関して何かコメントや質問ある人いますか。後半部分は数学学習の話になりますが。
Do you have a different qualification? Do you require different qualifications for teaching, for teachers teaching special ed?
Yes. Special education teachers have it is a part of the same teacher education model, but then during there are three different trajectories to special education, but this is a separate qualification, so that typically the teachers have a kind of double qualification. They have qualification as a primary school teachers and special education teacher, or they have qualification as
stay in university longer.
So it can be organized also within the degree, that it's not necessary very much longer. In reality, it's a little bit longer studies if they also have the special education.
How specialized are they? Are they specialized in, for example, are some teachers specialized in teaching deaf children, while others specialized in blind children, and in others are specialized in dyslexic children?
Yes. This happens, so that these teachers teaching the students with serious disabilities, deaf and blind children, they have a very focused education, and then there is the kind of general special education focusing on reading difficulties, mathematical difficulties, behavioral difficulties, and so this is more kind of unified kind of expertise what they should have.
I have another
Yes.
question. So you said part-time teachers, help
Yes.
teachers working?
Or not part-time teachers, but that is part-time special education. The teacher was a full-time teacher, but the students are part-time in special education. Most of the time they are in the regular classroom, and then a short time they are in the special education.
Students are part-time.
Students, yes, it was.
Teachers are not.
No. I'm sorry if I was unclear in describing that.
Okay. So there are no concept of part-time teachers that just help particular group of children.
No, basically all the teachers are full-time teachers, and then in primary and secondary, lower secondary, upper secondary level, and then maybe in upper secondary level there are some very specific topics where we need only a little bit teaching, and there we have part-time teachers. But then these helping people, some of them work full-time in school, some part-time. They are typically people who want to become a teacher. They have graduated from high school, and then they work one or 2 years as a helping workforce in a classroom, helping the classroom teacher. Okay, any other questions or comments? Okay, then I go to this mathematics stuff. There have been a lot of research on the early development of mathematics, and during last 20 years, different this very basic cognitive studies and neurocognitive studies, they have and then some innovative methods in developmental psychology. They have opened new understanding of this early development, and there seems to be that human beings have this kind of innate predispositions for understanding quantitative information or quantitative situations, and now clearly seems to be two systems. There is this so-called approximate number system, so that but that's not only small children but also animals seems to be able to recognize which set of items is bigger if the ratio is big enough. But if they are close to each other, only then more experienced and older people can or older children can recognize it. But if the ratio is big enough, so already infants can recognize which set of items is bigger. Which that takes too much time to go to these habitation experiment methods which have been made it possible to study this kind of issues. But these are very innovative developmental psychology methods. And similar findings come from cognitive neuroscience that this kind of this approximate number system exists. But this is not about exact number. This is just noticing this the difference if the ratio is big enough in the sets. But then there is the other kind of ability, which is so-called object tracking. Now I didn't object tracking system that which makes it possible for already an infant and also for many animals to recognize very small numericities, and for example seeing the difference between 2 and 3, or 1 and 3, or 1 and 2, but not anymore between 4 and 5, for example. So this doesn't work anymore with this system. Okay, now it's the large agreement that this is a kind of, this initial number sense is a kind of starting point for developing numericity. And then we have the kind of culturally mediated or culturally developed mathematical knowledge, number words, number system, mathematical operation, counting processes, and so on. A lot of these kind of things which are cultural in origin. And then how this combination happens. The kind of standard explanation is that, okay, then in families, parents are telling, helping students to learn to count and using counting words, teaching them the words, and then it is somehow connected to the initial number system. It is still a little bit open that how that exactly happens, this connection. But basically the idea is that this. But when we started to look carefully at this early development of number concept, we were thinking that this cannot be the whole story, but there is something else, and this is the children's own mental activity and practice with numbers and quantities, which happens also when there is no guidance, when nobody is telling them that, okay, now this is about numbers, now we count, but what happens independently of adult guidance. The origin for these activities can be triggered, so that they have triggered in social interaction with others. But this kind of self-initiated practice seems to be something which children do. And we started to look at that much more carefully, and our empirical studies made it possible to propose a new concept, which is that spontaneous focusing on numerosity, which makes this self-initiated practice possible. And if you think a situation when person noticed that there are two of something or three of something, then it means that the person have to focus the attention to this the numerosity aspect in the world, and then the carving up of the set of these objects is the other aspect of that. It is not an automatic process. If we come into this room, it is not that we automatically, in a way, see different numerosities. We only see the numerosities if we focus on the numerosity of something. For example, how many shares or how many papers here is. And so that this is a kind of, it is not necessarily a conscious, but it is a kind of active focusing process which happens. And so this focusing on numerosity is a separate sub-process of then exact enumeration, where we before we notice these numbers. And now when we use the term spontaneous, it focuses on that this happens spontaneously in a concrete situation, but it doesn't refer to the origin, because this is very important, so that we believe that this tendency to spontaneously focus on numerosity is very much triggered by interaction with adults. Of course, there can be many things to do that, but okay, this is the background. And how we came to this kind of findings? We started to experiment with very young children, so that these were about 2 years old children, and we had many kind of situations. This is one situation. We had this bird figure, which is called Vaakku. And then the story was that bird likes very much berries, and then we cannot see here is a plate where they have this kind of glass, small glass pieces which looks like berries, and then the experimenter say, now look carefully what I do. And then she takes a berry, put it in the mouth of that bird, and when it goes down, we can still hear cop. And then put one berry, and then the second berry, and then say the child, okay, look what I did, do exactly what I did. And then when we observe the situation, there are children who put all the berries from that plate to the mouth, or just put one berry into the mouth. And then there are other children who systematically put exactly the same amount of the berries in the mouth than the experimental did. And then that was repeated many times with a little bit different berries, different figures, and there were also different forms. This is another type, that there was a dinosaur figure, and then there were two pictures. The experimenter had one and the child had the other one, and then the experimenter took a stamp and made these spikes in the her figure, and then turned it upside down, and then told the child, do exactly what I did. And then again, some children put all kind of spikes to their or practically everywhere when it is possible to do it, or then just randomly did that. And some children always exactly the amount of spikes the experimental had made. And then there were many other tasks that have been used, and so it was clear that there were relatively stable tendencies in children in these situations where they had no idea that this has nothing to do with numbers. That was important in these studies, that was completely unknown, that this nothing to do with numbers, but they focus on the numericity. And then some others didn't notice on the numericity. So then for a bit later, as children, we used this kind of figures that we did say a series of this kind of figures, and we asked them to explain these figures. And again the same. Those children who did pay attention to numericity, they reported the number of trees, for example. And interestingly, we still found these differences among adults by using these picture tasks. And so, if I go to the findings now, these methods have been applied more than 20 research groups around the world in different countries. In addition to Finland, in USA, Belgium, Germany, Austria, Switzerland, and also in some Latin American countries now, and many places. And there is the replication studies in different countries give the same findings than our original findings, that 3 to 7 years old children, which we studied in the beginning, have substantial individual differences in their spontaneous focusing on numericity. Then I promised yesterday that I will show one example of brain imaging studies where it really was important, and because now if we have the situation that there is a systematic difference, that some children always report the number or do something exactly according to the number. We still have the problem that we don't know, is it something which is already in the perception of the situation, or is it something which describes the tendency to make use of that numerical information or tell about that? And if you think that problem, we cannot solve it by using any behavioral methods. And then we carried out brain imaging studies with children EEG studies and with adults fMRI studies. And these studies clearly show that in those cases when the person reported the numericity, these were the picture studies, there were... Yes.
So you presented this kind of picture,
yes,
to subject, and then asked, what did you ask them?
Ask them to explain the picture.
Okay, talk about the picture.
Yes.
And then the Swan students or Swan participants spontaneously refer to the number.
Yes.
Whereas
yes, they of course described also some other aspects, but systematically the number. And then the other participants described other aspects, but never but not the number. Mm-hmm. And then we compared these cases when they reported number with those cases when they didn't report number but reported color or something else. And this did show that there was activation within a first 100 milliseconds in the fMRI studies in the areas which are known to related to numerical in processing of numerical information. So that similarly the EEG study did show the same, that it is already in the perception. It is the difference. It is not in the tendency to make use of that. So that already in the perception of the situation, there are differences if the people are swanning.
The only difference that the activation was stronger for Swan.
See, fMRI always is a comparison, so that if it is a statistical significant difference, and these colors, the beautiful colors you see in the brain imaging task, these are just a kind of visualization of statistical difference. And if there is a statistical difference, that these brain areas related to numerical cognition and activating more, statistically more, then we can conclude that there is a difference. And
I'm sorry, so statistically more than what? So what's the control, what's the baseline?
So the baseline, this is a contrast. When we compare cases where they then later on report numericity or don't report the numericity. We contrasted this.
So you are comparing across individuals?
No, these are not group individuals. These are these cases, because in each picture we get this information that did they report the numericity or did they report color but not the numericity, and these were contrasted, and this did show that if they reported number, there were activation of statistically higher activation of numericity.
Looking at individual difference?
No, not this in this study, because this was better to make in this way, so that we looked these cases when the activation happened, when it didn't happen. Okay. So, and then I already told that there was kind of modern stability between different task types. The strong stability between different task types, but also moderate stability we did find, for example, from 3 years to 12 years, so that there was a relatively high intra-class correlation, so that the tendency to pay attention is somewhat stable. And then now there are plenty of studies showing that longitudinal studies showing that the differences in Swan are positively related to the later development of the system of natural numbers and arithmetic skills. First before school age, and then later on there are studies now showing that also during the first school years. And this is one of our relatively late studies. There I don't. It's to take too much time to tell what the subitization is, but I go to the Swan studies when children were 6 years old, and we measured the Swan tendency, and we also the counting skills, and then we looked the overall mathematical skills at the age of 12, and both these contributed to the mathematical skills, but Swan was a stronger contributor to the mathematical skills. And this finding has now been replicated in many studies in many countries. Then we also looked that we had this 12 years old population, and then which we had already measured the Swan at the age of 6, and then we measured it at the age of 12, and they still correlated highly. And then we looked how they predicted the new mathematical topic which students were studying at the age of 12. It was the rational number knowledge, so fractions and decimals. And the Swan measured at the age of 6 predicted the fraction comparison, which is very important for the conceptual understanding. Also fraction density and decimal density, understanding the rational number system, that because density is very important aspect of that you understand that between any two rational numbers there are infinity number of other rational numbers. That if we have, for example, 2/4 and 1/4 and 3/4, there's not only 2/4 in the between, but infinity number of fractions in between. And this understanding, which is very difficult for children, it seems that Swan predicted. But interestingly, Swan measured at the age of 12 didn't predict that. Our explanation was that, okay, this is a very important tendency that children develop the Swan tendency very early on. We have noticed it that 3 years is age when it becomes already relatively stable, and then we have intervention studies which show that we can enhance Swan tendency. And then we started that discussion in Finland. We presented all these results and discussed with people teaching primary school, pre-education teachers in universities, and then we discussed with the teachers and administrators, and gradually now these ideas are implemented in the national guidelines for early education, because in early education there's no formal teaching, but the idea in the daycare centers and in the preschool education, the idea is to support this kind of mental processes which are important for later school learning. And now, earlier it was mainly only about language. Now the triggering on spontaneous focusing on numericity is one implemented there in these general guidelines. And also the idea, what is important here is that now mathematics, when it starts in the beginning of primary school, is there's now we emphasize the continuation. It is exactly the same that children do in all kind of everyday situations, and this idea is now important issue in the during the early years of primary education, so that we try to guarantee that mathematics doesn't become a isolated piece of subject. Well, that's something which which is a kind of natural way to see the environment. And that's, we believe, important in long term for the motivation of mathematics. But what was the problem? Okay, but then why we started to look the fractions? That was also came from the early studies showing what was the problem in Finnish education. That's of course a problem, particularly in the Western countries in general, that rational numbers is very difficult to learn, to understand them properly and to use them in practical situations. So that's why we focused on rational numbers and started to analyze them. And one of our studies have been that what happens when students move from natural numbers to rational numbers. There is now intensive tradition in there are a lot of this research in Europe and also somewhat in America about the conceptual change processes when students move from this more early number concept to more later number concept. And there are many changes. In natural numbers, it's simple to see what is the magnitude of the number, how big it is, but in rational numbers it's much more complex. Then ordering, what is bigger, is very simple in natural numbers, but when we ask which is bigger, it's much more complex. And then for natural numbers, if we have number 5, there is the successor, the second number, it's 6, and then after 6 is 7, and this is very fundamental experience for young children. But in rational numbers, there are no. What is the next number after 1/4? You cannot define it in the field of rational numbers. So these are fundamental differences which make it difficult to conceptually understand rational numbers. And then we have made a lot of studies about that. This is now only one example of our studies where we looked the long-term development of natural numbers, and here we used the method that we looked this kind of latent profiles. If we looked at different aspects, comparing rational numbers, ordering the numbers, and a density concept, we did find that there is a low group who are cannot do anything of this. Then this average group which can do somewhat, can understand them somewhat, and then a group which understands the comparison and ordering, but the density is extremely difficult. There's only this highest group where they reached the density, and then several later studies have shown that this is really so that there's an order of difficulty, so that first students have to learn to understand how to see the size or the magnitude of rational numbers, and then later on they can understand the density. And then when we have looked that this low group is very stable, that was 1.5 years period. This is not developing at all, but here are the changes from the average group to the magnitude representation group. But then again the high group is very stable, so that it seems that this is a kind of very difficult development which is taking place in the field of rational numbers, and it requires intensive new approaches, how we can help students to understand rational numbers, because there are many reasons to think that this is now one of the very fundamental.
What study you want to see? How are they
This was 1.5 years.
1.5 years.
Yes.
Between time 1 and
Yes,
2.
sure, yes. And this leads us to look at, okay, would there be something similar which is this kind of more advanced spontaneous focusing tendency than this spontaneous focusing on numericity. And then we started to look systematically these topics. We first made that with younger children. We had this kind of situations that, again, this feeding task that these are brothers, they like very much bread, and they always do the same. They eat the same, they jump as high and whatever, so that the children knew that they are. And then we gave them, the researcher gave them bread from this plate, gave one piece, and then they say that unfortunately the bread is broken, but you have you make the same. And then we were looking if they give. If they focus on just on a number that they give one piece, or if they look the relational aspect, that okay, in order to make the same, they have to give two pieces of that. We make the same with rice, so that we had different sizes here, that the researcher gave with a smaller one, or the researcher gave with a bigger one in different trials, and then again we looked what happened then, and again the child had no idea that this has had anything to do with mathematics or numbers, and this was related in the very similar findings than the Swan findings, that there were strong tendencies to pay attention to relations or not to pay attention to relations. Of course, there now it's a question that this already requires some skills that they have to be able to be, but I come back to that. Okay, this seems to develop by age, so that first students pay attention to numericity, and not first students pay attention to numericity, but then it goes down, and then only earlier in the beginning they do not pay at all in relation to the relation, but then it's improving, and then there are students who have some other which is not non-mathematical aspect. Then in a little bit older population, this relation is the same, so that this relational thinking, focusing on relation, is improving by age. But still, in the 9 years old, in this task, it was not completed. But we noticed that this is relatively easy task for 9 years olds, so that in our later studies we developed other tasks. But we already noticed that when we measured these skills in the first grade, and then looked how they learned fractions on the fourth grade, there was this focusing on relations predicted fraction knowledge. And then we developed a new, more bigger longitudinal study on a little bit older students, and there we needed new tasks. And so I go to the tasks in order to be. This is our teleportation task. So and here the story is that in future there is a space station, and we have to send from the Earth things to the space station, and we need to that's very complicated, but fortunately a teleportation system was developed. But because it's a prototype, it's not completely reliable, that something happens in between. And then this is an example. These things were sent from the Earth, and these came to the space station. Please tell what happens. And that was completely open task. And then after they had explained that, then they gave a written answer to that. and we give this kind of figure that, okay, make use of the previous picture, and now these things have been sent, what comes to the space station? And then they had to draw it. And we continued it with more kind of naturalistic things, so that these many things change here. And but of course you can see that in all of them there's a kind of multiplicative change. They should see that there's one change which is stable in them, that all these things are in this case 3 times so many, or here they were half of the task which were sent. And this resulted also very stable results, that students in this task and then in our second task, where the story was that it's important to eat healthy food, and then we had different plates and they had to explain the plates. And again, if students reported the relational aspect, that how different things are related to each other, then they were scored as focusing on quantitative relations. So that we got a relatively high overall stability, the overall kind of reliability of these tasks. And then there's, of course, these are very much related to the mathematical skills. And we wanted to be sure that when we use measures of spontaneous focusing, this is a poor measure of spontaneous focusing, and that's why we use so-called residualized tasks, so that we explain the SWOR with understanding of rational number, that these relations, and then residualize them so that we got a poor measure of the SWOR tendency. And this now explains that when we looked at rational number understanding in a long-term measure, then and this is the latent core model, we see that there were 2 aspects. There was this residual SWOR score and non-verbal intelligence, which was measured with Raven matrix. These 2 predicted the level of knowledge and then how quickly it was developing this slope aspect of the development, so that it seems to be a very strong predictor. And here we see a kind of development. There was a reciprocal development, so that the conceptual understanding of rational numbers was the earlier SWOR was predicted conceptual understanding. Conceptual understanding predicted later SWOR, and again SWOR. So that this kind of focusing that we learn to see in our environment relations is a tendency where children are different, and if our understanding of rational numbers develops, our tendency to focus on all kinds of relations in our environment increases, and this again makes our rational number knowledge stronger. And this again have now leads to training, so that we have a large training program where we are training students to focus more on relations, and this is related to large teacher in-service training programs as well. Okay, the other aspect we were thinking is very important is now something which many countries have added to the curricula, that students should learn adaptive and flexible skills. And that was also some of our earlier findings, that even good students in mathematics were not very flexible in using their mathematical knowledge, and we because we focused in this question very much because we noticed that there were many students who were particularly boys, who were relatively good in mathematics and were not at all motivated in mathematics. They explained that this is very boring, they do not know where they could use that, and because they had considered the knowledge in a very mechanical way and learned mathematics in a mechanical way, and this didn't support the motivation of future learning of mathematics, and that was the reason why we started to look these flexible and adaptive skills. But that's also something which has been studied quite. For example, USA, Bob Siegler has proposed the flexible strategy use in arithmetics, and Lieven Versaffel and his group in Europe have done a lot of this research. There are Australian studies and many. But we started to look at a little bit more from the point of view of more rich mental representation of networks of numbers, and this is an example of tasks that we have developed to measure that, because the problem in the world, many people talk about flexible adaptive skills, but there's no systematic methods to measure them, and now we started to develop them. This is one example, so that we give numbers, for example this 6, 4, 2, 24, 16, and then operations, and then one target number, and then in 90 seconds students have to give so many sentences as they can by using all these numbers and all these operations, which equals 12. And then this can be scored in so that we just focus on correct solutions. But what we have learned, even more better predictor of this flexibility, if we, in addition to that, look so-called multi-operational, so that where they use the multiplicative and additive operations in the same sentences, and this is now something which has proved to be, and we have some similar other measures for the flexibility. Okay, but how to enhance in teaching this flexibility? And we were looking at literature and noticed that there were some strategies, some approaches to teach explicitly a couple of strategies for arithmetic tasks, and then how to choose between them strategies in certain connections. But then when we looked for example, in the Netherlands, they have applied that model. Then when we looked in big studies in the Netherlands, what have been the consequences of this? It was clear that they have not improve this general flexibility, this teaching of specific strategies, and then, but there were many researchers have criticized that as a too narrow way, that there were no kind of methods then to teach these more general numerical representations which would have been implemented. Many researchers recommend this kind of playful activities with numbers, but then how to implement that in a real situation. And it is clear that this kind of flexible number system needs that there are a strong representation of the number system, and there is opportunity to explore with numerical relation, and then what is needed, a very big amount of training, but not that kind of simple training, but this kind of deliberate practice where they push knowledge forward in a very systematic way. And the only idea we got was that we have to develop a game to support that. And the first game we developed was the natural number navigation game. And there the idea is that there is the archipelagos, and there are materials, and there is a harbor, and then when the player go with the ship to pick up these materials and bring them back to the harbor, then a small village becomes a town, and then a bigger town, and so on, that these materials can be used. And there were in this first version 46 maps and several materials in all these maps. And then we started to experiment with that game. We had a randomized experiment with more than 1,000 students. It was 10 weeks play without any specific teacher support, because we were focused on the effects of the game in the first phase. And the results did show that there was significant for fourth graders. There was a significant improvement for the fluency of mathematics, and for fifth graders there was improvement for the more simple measure of the adaptive number knowledge and the flexibility, but also for the more advanced, this multi-operation. And then for sixth graders, there were a strong improvement of this multi-operation, and also improvement in the pre-algebra skills, which we think is important for that. So that was very promising, but on the same time it was clear that children didn't like this game at all. It was too boring for them. And then there were two solutions. One was that we carried out a second study where we integrated it with an effective teacher scaffolding. So the teacher took a part of a kind of professional development course where they learned to understand the ideas. Of course, there were only two teachers who carried the experiment, so that it was a small scale, but we very systematically helped them to understand these ideas, and then repeated the study with a little bit developed game. And now we got for fourth graders strong improvement for fluency, adaptive number knowledge, and then pre-algebra knowledge. So that it seems that this game, when it is combined with teaching, really can improve this kind of flexible mathematical thinking. But then the second solution was that now we have realized the game in totally different way. Now it looks as a commercial entertainment game, but the game mechanism is the same. And now we start experimenting what now happens when and we already know from some pilot studies that students like it very much, but does it lead to better results? We do not know, and it can be that they pay more attention to the entertainment features and less into the mathematical features. Okay, then still we also have started to study the adaptive rational number knowledge. To look how this developed by using basically similar tasks, but with rational numbers, that they have to create these target numbers from these rational numbers in a short time. And then we already have carried one relatively big study. My postdoc researcher is originally from California. He was mathematics teacher there, so that it was easy for him to get students. So that this is from no, not California, from Florida. This U.S. group, and there then we looked with these tests where we used the rational number conceptual test, the understanding the magnitude, then arithmetic procedures with rational numbers, then this kind of understanding the representation, so what is the relation between fractions and decimal numbers, and then our adaptive number knowledge task. And we did get with this latent profile analysis 4 profiles. There's the weak students who do not know almost anything about rational numbers. Then there's this interesting group of students. They have no conceptual understanding, but they are almost as good as the top students in these arithmetic procedures with, so that they can repeat mechanically the procedures, but they don't understand practically everything, anything. And then we have the traditional good students who have top achievement in this conceptual knowledge and procedural knowledge, but not in the adaptive knowledge. It's clear that there's this small group of students who have high-level conceptual understanding and procedural skills, and in addition to that are flexible and adaptive thinking. And now this is interesting, that how this can be developed. Because this is something that we know now from some studies from the need of mathematics in future working life. They emphasize exactly this type of flexible and adaptive use of understanding quantitative relations and the use of rational number knowledge in many kinds of situations. So we only have one explanation at the moment. In the same study, we earlier studied the Swan tendency, the tendency to pay spontaneously attention to numerosity. Then we had the conceptual knowledge measured earlier, and this model tells that adaptive rational number knowledge is, of course, explained strongly by the conceptual knowledge, but also the spontaneous focusing on numerosity based on attention. Okay, so these findings of the adaptive number knowledge and the flexibility are now implemented in very large teacher in-service training in the Finnish education model. We got funding from the Ministry of Education to run for several thousand students, teachers, in-service training, and it is organized so that we go the theoretical background and experiences from all over the world about ways how to teach flexibility, and then they play our games. We have the natural number navigation game, and also rational number navigation game has already been developed. And simultaneously, when they take part in this in-service training, they have these games and also our task which we have developed, these electronic versions of the task which they can use in their own classroom teaching. Okay, thank you very much.